seems like a while. It is. It is. But some of those 21 days we're not together at all because classes end, a week from Thursday, 2 weeks from yesterday. We're done with classes. So. All right, here we go. First formula, arc length. Not given, need to know it. Arc length of a circle. A reminder, and I think I just kind of decided I'm going to cave. I put this formula sheet you need to know up on the on Google Classroom, but I think I'm going to print it out and copy it for anyway and cave and cater to you guys like usual. All right, so I will do that, but of the 15 formulas that are on there, length of an arc is one of them. So here you go, length of an arc. It's not even a formula. It's kind of it's a word. If you remember when I showed length of an arc, SOR. Remember SOR, S equals theta times R, our Greek letter there, theta. That's just a variable, usually represents an angle. There's no A in there. All right, deal with it. All right, each variable, let's go. Each variable, S is your arc length. That represents the arc length, S. Theta, that is your central angle. Okay, that is your central angle. And this is probably the most important part about this formula. You can't just use this formula anytime you want. That central angle, that theta, must be in radian measure. They must be in radians to use that formula. Well, what if I'm given degrees, Mr. Carlino? I'll show you how to convert on your calculator in a minute. But to use this formula for theta, that angle has to be in radians. And then, hey, what do we think for R? Oh, there you're on your way to 100, Josh. There you go. Radius length. Good. There's your radius length. Yep. So that's how to find arc length. Arc length equals the central angle in radians times the radius. So go back to problem number 1 now. Let's go back to problem number 1. How do I know I need this formula? You read the directions right away. It says the arc length is 2 pi. Okay, arc length. We're dealing with arc length. It's got to be SOR. And I'm going to turn this over to you guys now so you can substitute in the 2 pi and the 10 correctly. So identify arc length. Let's start with the 2 pi. Where should 2 pi be substituted into the formula for? Read what it means so you can substitute it in correctly. Where's that 2 pi being substituted in for? Here we go. Doyle? S, it's the arc length. Great job. So 2 pi equals, where's the 10 getting plugged in for, Zoe? Radius, and I'm solving for theta, which is my angle. All right, how do you move the 10 over if I'm solving for theta? How do I move that 10 over? Ksenia, what do you have? Divide it over, perfect. Divide by 10, divide by 10. And lucky for you guys, because it does everything for you, calculator does leave it in terms of pi, which all my choices are. So in terms of pi, what are we looking at here? Aiden? Pi over 5, good. All right, let's stop here for a second. I know we answered the question, but let me change up the directions. All right? Okay. It gets annoying sometimes, but on one hand, I get to get rid of stuff I don't need anymore. But on the other hand, it's like I'm in a good flow, it's going great, and then I got to stop it. I'm not giving away that. I need that flicker. There we go. I'll give away. You guys can start writing your formulas on your index cards. All right, there you go. Something useful, maybe. And the poor people have to listen to this video. Okay, now no excuses. All formulas are going to be correct when we correct your Regents exam there. All right, all of them better be correct. All right, fill that sucker up. All right, we good? All right, back to what I was about to do, which is let me change the directions in degrees. I want it in degrees now. Okay, so you solved it in, you understand, all right, if I'm going to use SOAR, my answer is going to be in radians. So let's go over how to convert it on the calculator. Make sure you're in degree mode, please. Everybody in degree mode, top left-hand corner, we're in degree mode. All right, first thing we got to go to calculation screen. And we got to tell the calculator we're about to put in pi over 5 radians. You just put pi over 5. Calc's not going to know what that is. It's just going to assume it's pi divided by 5 and give you an answer. We need to tell it that is radians by attaching the radians name and unit. And the way we get that is go to your toolbox. And probably most of you are there because my previous classes had to do this as well. But if you're not there, take a look at mine then. If you're already there, you got to scroll down because you got to know how to get there. Scroll down to where it says units and constants because we need to apply a unit to pi over 5. Hit enter. Now you have a bunch of units and constants we need, but we need angle, right? Length and angle. And then we need angle because we're talking about an angle measure. And then up pops all the different units you can label an angle, and we need radians, RAD. So we put RAD with it. And then we hit enter. And now you have 36 degrees if it asks. Okay. Going backwards, heads up, going backwards. All right. Let's say I had an angle of 90 degrees that for whatever reason you needed to turn back into radians because the direction said answer in radians, not degrees. All right. So I type in 90, but again, calculator just thinks that's the number 90. You go back to your toolbox, same screen, length and angle, and everyone see the degrees. But something interesting is going to happen here. You're going to assume that it's just going to give you radians back, but you hit enter, and what happens? It just gives you degrees back. Why? What mode are you in? You're in degrees, so your calculator is just going to give you degrees. How do you get that radian? You don't need to change your mode. You just highlight it, go over to those 3 dots, and it'll tell you what it is in radians. Okay, so just a heads up, depending on which way you want to go back and forth from radians to degrees. Okay, all good? So now we know how to convert if we ever need to have to convert it. Thank God for this calculator, huh? So we're good there with number 1. Let's go to number 3 now. You're going to do number 2 on your own. Let's go to number 3. We had arc length. Now we're going to go to sector. Remember, this was called a sector. 2 radii connected by an arc. So how do I find the area inside a sector? Area of a sector. Another formula, not on the formula sheet, but hey, look at that. It's on our ones we need to know. All right, here we go. Maybe some of you remember it. So area equals measure of the arc over 360. And anybody want to finish it? I'm going to multiply it by Matt. You might want him to take it, but go ahead. All right, both of you combined should be able to get it. Let's face it here.
I was just guessing.
Do you want to discuss with each other here before somebody says it?
I just said radius because that's like a thing. It's a circle. I was thinking pi r squared though. It sounds like pi r squared. That sounds all right. It's the area of like a whole circle. Yeah.
One blind squirrel can find an acorn, so can 2. Good job. Yep. Yeah. Pi r squared. There you go. Way to discuss it. Unfortunately, the Regents isn't a partner exam. Might be the only way we hit that 100. Yes, times pi r squared. All good? All right, let's go to the problem now, number 3. Now that we have our area of a sector. Read through everything so you know where to substitute it in carefully. Read through everything. Let's start with the 12 pi. Read what the 12 pi is. Where should I substitute it in for in the formula? Where's the 12 pi going? Ian?
Measure the arc. Or area.
You sure? Yeah, it does say the shaded sector has an area of 12 pi, so we'll plug it in here. 12 pi equals, where's the 6 going? That's not a bad question, I don't think. Where's the 6 going? Ian, again, where's the 6? Radius. So, hey, whoa, wait. The only thing I have left to solve for is the measure of the arc, but it's asking me for angle AOC. Is that going to be a problem if I solve for the measure of the arc? Nope, why not? Because you know a circle fact that says what? Central angle? You know how to kill a fire. Central angle always equal to the measure of the arc. So it doesn't matter. You find the measure of the arc, you found the central angle. All right, let's solve for this bad boy. Hopefully nobody has a problem with me getting rid of the pi's now, since they're on both sides of the equal sign. 12 equals x over 360 times that 6 squared is bothering me, so I'm going to put 36 there. You could go 2 different moves now to get x by itself. I'll go with your move. What do you want to do next? Zoe, I'll go with your move. Yep, that's what everyone's doing today. If anybody wanted to multiply by 360, you could, but we'll go with Zoe and divide by 36. So what's that, of 1/3? Equals x over 360. I don't care if you multiply by 360 or cross multiply, get after it. So I know what this angle is. And what are we looking at angle AOC? Thomas, angle AOC?
I did something wrong.
Recalculate, here we go. We're down to 1/3 equals x over 360.
Oh, 120.
120. When you use this formula, it is in degrees. And if you go back, it just says determine and state the angle measure. So I could leave it 120. You could leave it in radians. All right, we know how to convert now, so it doesn't matter what we leave it in. Everyone all right? Okay. You need some soap or something to you good? All right, everyone else all right? Okay, so there's area of a sector. Well, we stay in the whole circle family and talk about the equation of a circle now. That's going to come up somewhere. So let's first talk about, we're on number 5, sorry. Equation of a circle. This is going to come up. All right, here's the equation of the circle. Oh, also, again, conveniently located on your formula sheet. There, where is it? Circle equation. Yep. Here it is. X minus h squared plus y minus k squared equals r squared. That's called the center radius form. It can come in another form, as you see on number 5, but that's called the center radius form. There will be 2 parts to this formula, 2 parts to this equation. There'll be a number plugged in for h and k. You take those 2 numbers in for h and k, put them together as an xy coordinate, and that'll give you the center of the circle. Yeah. That'll give you the center. Good. And there will be a number plugged in over here for r squared. We're not concerned about that number. We're concerned about the r value, not the r squared. And that'll give me radius length. Okay, and that'll give me radius length. So there's your equation of the circle. Gives you radius and center. All right, ready for number 5? Oh, unfortunately, look at that. It's not giving me the center radius form. It's giving me what's called standard form. So I need your help right now converting this into this form, right? And it's a process that you learned initially in Algebra 1 last year. Anybody remember the technique to get that into center radius form? Completing the square is easy. Yes, we are going to have to complete the square on the standard form to get it into center radius. Yeah, anybody remember the first step? Anybody? First step? Hey, got it, Haley?
Combine like terms, right? Like
I know what you're talking. Yes, reorganize it. Reorganize. So the x's are together and the y's are together. Were you going to say that, Matt?
But no,
I think maybe you're thinking a couple steps ahead, maybe. Okay. All right. Here we go. X squared is going with the negative 2x. Y squared is going with the 6y. And part of this reorganization is getting that constant, the one without a variable, to the other side. All right. I don't want it equal to 0 unless 0 is that number. So move that 3 over. Everyone should have a negative 3 over here now. So reorganize is step 1. Step 2. Notice your x's have an a and a b value. Your y's have an a and a b value. You need to come up with a new c value for each of them now. All right, we need to calculate a new c value for each of these. So x squared minus 2x plus, ready? This new c value that you'll calculate for me. And I got to do it with the y's as well. Y squared plus 6y plus new c value equals negative 3. Is this where you're thinking about, Matt, or no? It was? How to get the new c value? Is that what you're thinking about?
Yeah.
Well, okay, go ahead.
Well, I was just going to say we have to get a new C value. But I think you
This guy.
I think you divide by x. Or divide by 2. Divide x by 2. And then add it to both sides.
Missing something. You do divide by 2, but then I need another step right after that, which is
Base square it.
square it. Yes. So you take your b value. I don't like to say the x. The b value, you take the b value of each, divide it by 2 and square it. That's how you get your new c values. Okay? Divided by 2 and square it. Look at us working like a team today, huh? All right, so negative 2 divided by 2, square that bad boy. We end up with, where am I going? Gianna, what do you got for that new c value? 1, good, that's a 1. And what about over here? Y squared plus 6y plus divide by 2 and square. Divide by 2 and square. Aiden, 9. Yep. Don't forget this piece now. I promised when I taught this to you, it would be the only time I did it, but I guess I lied because I got to do it again. You guys were here, right? And then all of a sudden that 1 and 9 came into play, and now we're here. What needs to happen other than me getting some self-respect? Balance the darn thing. Balance it. So make sure we add 1 and add 9. Balance it. Next step. So we found the new c value. We balanced it. Not going to like this, but it's factor time. But not that bad. Not that bad. Take a look at this first. Factor the x's. 2 numbers that multiply to 1 but add to negative 2. In case you didn't hear me, honors kids, let me do that again. 2 numbers that multiply to 1 but will add to negative 2. These 2 numbers multiply to 1 but will add to negative 2. Do you have those 2 numbers ready to go? Haley?
Wait, it's multiplied to 1.
Yep. You got it.
Negative 1. Negative 1.
And?
Negative 1.
Yes, negative 1 and negative 1. And when we complete the square, those 2 numbers should always be the same. Because I don't want to write this in the next step. I'm going to write the professional version, which is x minus 1 all. Now it's starting to look like the circle equation. Plus 2 numbers that multiply to 9 but add to 6. Multiply to 9, add to 6 here. Oh boy. Amy?
3 and 3.
3 and 3. And what do I get over here? 7? All serious now, joking aside. If you get nervous or pretty high anxiety when you're trying to factor. I know you get nervous. I know even the honors kids do. The quick trick was take your B value and just divide it by 2. You'll get that number. So if you don't want to factor, you get nervous about your ability, just take that B value and divide by 2. You'll get that number. So what do I end up with? 2 is my answer?
I know you should call in someone's.
I should, right? Aiden? 2. Thank you. All right. Bonus, though. Bonus. I have a extended question on this. I don't really think they're going to ask what's equivalent to it. Here's what they're probably going to ask is they'll take that equation I gave you, now find the center and radius for me. That's probably what we're looking at as far as the question. What's the center and what's the radius? So using my equation, what must have been the center and the radius? And just a reminder, it's x minus h and y minus k. So what must have been those numbers for my center? Be careful. What must have been my center there? Charlie? 1, -3. Nope. Nope. I know what you're thinking. Wasn't the full answer. Sorry, it's only a half answer. We good? And what about the radius? Because it's not 7. Remember, that's r squared, right? That's r squared. So I don't want to put 7 down. And just give me the radical version, please. I don't need the full decimal. Matt? Yeah, the radius length, if there's a 7 in for r squared. What's up?
Radical 7.
Yeah, that's it. That's all I need. It didn't break down, so radical 7. Good. We had so much fun doing that problem. I did anyway. I think we were going to do number 6 now together, which is take that and find the center and radius from it. Now I get it. Some of you in your mind, right? This guy's nuts. I'm not going to do all that work again. I know. I'm fine completing the square. Get off me. I'm fine. Can we just go to the next topic? I'm not going to have you complete the square. I could probably told you this while I taught you the circle unit. Remember on not Monday, where we were off. Tuesday, when we did equations of lines, and I showed you on your calculator can tell you what the slope and the y-intercept is. It can tell you what the center and radius is as well. All right. Yeah, I know. I'm going to say I'm sorry, but I'm lying through my teeth. All right, that I should have showed you this earlier in the year. Go to Grapher. Just like we did with the line, go to Grapher. Go ahead, type that circle equation in for me. And when you hit enter, hopefully the word circle pops below it. It tells you, hey, it's a circle. And we are going to get the center and radius the same way we got the slope and y-intercept from a line on Tuesday, which is go to your 3, when you're ready, go to your 3 dots. Okay, go to your 3 dots and get some details. Look at this. Are you kidding me?
It's on the Regents, we still have to show.
We're going to talk about that, young buck. Can anybody and this happened to a couple calculators in my previous classes, but I think you guys should be fine. Is anybody's details not coming up? It's not time. Okay, flip it over for me. I got to reset it. Oh, this is yours, huh? Okay, that's fine. Actually, hold on. I got to make sure you got the most updated version because these things are like your phones. Okay, I don't know if this is going to make a difference or not. Let's see. Okay, try it again and let me know. Okay, I just reset it.
I don't have details.
What?
I don't have details. Lost cat.
Let me know now. Try it again. And then I definitely got to get to Ian's comment there.
What?
About using this on the Regents exam. No? Works now? Okay, perfect. Matt, you should be fine now. Okay. Look at this too, huh? Can you believe this? tells you the radius, and doesn't even tell you the center. It tells you the x and the y coordinates, so you can put them together. Huh? Look at that. All right, now let's talk here. That's great that I just showed you it, but really it only works if this is a multiple choice question. If you see this question on part 2 or 3, no multiple choice, you still have to show how you got the center and radius. Because here's what's going to happen. If you go right to your calculator and do what we just did and just write down center this, radius this, no work showing how you got it, you are only going to receive 1 point out of how many points it is. If you're okay with that, fine, go ahead, but I probably wouldn't be. All right, you're only going to get 1 point. You need to show work. All right, and on the Regents exam, any answer with no supporting work only receives 1 point. All good? So multiple choice, hey guys, go at it. Go at it, multiple choice. Use your calculator to find the center radius, but you are going to need to complete the square, I'm telling you. All right, so just don't think, oh, this little trick, and no more completing the square. No, you will have to. Okay? Matt, we good?
Yeah.
Yep. So what was that answer? 2 here? Sure, so I don't have to hear you. Will, answer 2? Oh, good job. All right, it was 2.
Wait, don't you like redo it when someone's done?
Sure, you got it. Why don't I redo it? 9, there we go. Are you good with the 2? Yeah, that's what I thought. Yep, right back at you. See the new generator, new karma. Questions? All right, last topic, and I know this topic is most familiar in your mind. All right, there we go. Perfect. Why not?
Wait, what?
We have them from the
I don't even. When I go back in the closet there, I'm sure there's stuff I want to get rid of. Oh, I know it. What do you think? I got balloons. We can give away streamers. I got a box of pens, staplers, box of, ooh, look at that, big box of markers. I got some tape in here. Streamers.
Yeah.
Party time. Streamers. All right, streamers it is. I got a little school spirit here. I think I got some black ones in here as well. Yep. There you go. Some school spirit streamers. Yep. There you go. Actually, you know what? Why not? We'll throw in some 72. All right, 72 helium balloons you can blow up. What a gift! What a gift! Is everybody all right with? Let's have a new person every time, because I know I'm sure Haley loved her CD. She wanted something else, and Gianna was scratching and sniffing like crazy last night. But we'll go with something else. All right, so every new person gets in every time, just to be on the fair side, so everyone's not hoarding these awesome gifts. 3, Aiden. There you go. Party at Aiden's this weekend. Balloons, streamers, not even open. Congratulations. All right, moving on now. I didn't need that page. You guys are going to do 7 on your own. All right, last topic here. Volume and density. There's no need to be, I'm not going to review any of these problems. We just finished the unit on it. But I am going to remind you, and I want you to put it at the top here so you see it every time you study. The Regents is going to do this to you. I guarantee it. They want you to fall in the trap door, which is they're not going to give you the same units. Okay, they're not going to give you the same units. I don't know if you guys remember because I've been keeping it because finally they're going to take the volume test after school today. But you had that fire pit example on the volume test I gave you last week where it was how many bags of concrete and it was feet, and then inches at the top. Okay, make sure all units match.
Is it bias or stuff to take?
What's that?
Is it bias?
Yeah, Mr. World Traveler. Yep, finally making them up today. Finally making the volume one up today, so he'll be caught up. And I can give it back on Monday to you guys. All right, so make sure all the, what? Yeah, Matt.
When can you not switch the units?
Okay, you do never switch the units after you find the volume. Switch the units now at the beginning. Okay? So for instance, you guys are going to do number 11 here for me. If you're going to do a number 11 on your own today, notice that the density is in meters cubed, Matt, but notice the bricks are in centimeters. Don't find the volume in centimeters cubed and try to convert it, because the conversion I give you does not work when the units are cubed. Okay, so that's why I always preach change the darn units at the beginning. All right, and while you're on number 11, 1 meter equals 100 centimeters. You'll need that conversion. Okay. Please watch it. And by the way, you also know the Regents will do it, and you know who else is going to do it to you on next Thursday on the review quiz? This guy. All right, I'm going to have a volume multiple choice on there, and I'm going to tell you the figure I give you has 2 units that are the same, and the other one is different, and you got to change it first. What, Matt? Question? Or are you just shooting? Good. Steve.
Did we just get the conversions to then?
What are we talking? Regents or next week? Regents. The Regents, it's either A, feet to inches, which you should know, or B, it's on the formula sheet. There should be this probably isn't a problem unless they give it to you in the problem. Okay, it shouldn't be anything you need to memorize except for feet and inches. Ian.
Are we reviewing for the review quiz?
What do you mean?
Like
Tuesday, we're done with the review packet. Wednesday is I'm giving you guys all 40 plus minutes to do whatever you want to do. Whether that's the extra questions, the homework questions you didn't try. Wednesday is totally your call getting ready. I got nothing to review for you. You guys know what's on there already. Okay, so that's what Wednesday is dedicated to. All right, so before we leave today, you guys have 2, 4, 7, 11. Okay, numbers 2, 4, 7, 11. I don't want you to do all the volume ones. It's not necessary. 2, 4, 7, and 11. 7's a beast, by the way. 7's a beast. Talk that through in your group or call me over. Also, for number 7, I'll give you a heads up. You're going to need distance and midpoint formula, and I'm not providing that. I refuse to provide that at this point in the year. Okay, so for number 7 and 11, you're going to need distance and midpoint for that one. Go ahead, Charlie. Go ahead, do your thing. Saw your log up over there. And there are your answers. 2, 4, 7, and 11. Good luck.